Alright guys, so we're going to go ahead and do this first one, right? So here we have Pythagorean triples of 3, 4, and 5. So now we're trying to prove it whether this is correct, right? So our first step is to go ahead and draw a right triangle. So here's my right triangle to the best of my ability, right? So then after that, we need to identify the length of the legs and the hypotenuse. So right away, you should be like, okay, so where's my hypotenuse? Well, I recall from yesterday that my hypotenuse is across from that 90-degree angle. So that means this is my hypotenuse. Now it does not matter where the A or the B is, right? So where my first leg is or my second leg is, right? What does matter is the way we place these numbers. Again, remember that the longest side is your hypotenuse, meaning that this H, or this could also be considered C, right, is 5, because that is my greatest number. Now this is 3, and then this is 4, right? Or this 3 and this 4 can be switched. It does not matter because it serves exactly the same thing. It does not matter. These two can be switched. The only one that needs to make sure, that we need to make sure that is this 5, right? Because that's our hypotenuse, that's our longest side. So now you may be thinking, okay, so how do I prove that this is correct? Right, so we're gonna go ahead and use the Pythagorean theorem, right? So from yesterday, we stated the Pythagorean theorem says that a squared plus b squared must equal c squared, right? So just remember, one square, so this square plus this square must equal this big square, right? And we don't want to be there counting square by square. So what we're going to use is the Pythagorean theorem. So now we're gonna go ahead and just write the numbers and replace or substitute in, right? We know what a is. A is 3, so instead of writing a squared, we're gonna write 3 squared. Plus we know what b is, which is 4, so we're just gonna write 4 squared. Must equal that c, in this case is 5 squared. Right, so now we're gonna prove that this side is equal to this side, right? So now this is where the simple algebra comes in. So what's 9 squared? What is 3 squared? 9. And then what is 4 squared? That's 16. And then what is 5 squared? That is 25. Right, so now if we add 9 plus 16, it's 25. We bring everything else down, 25. So this is where you have to think for yourself, right? So is 25 equal to 25? Yep. Right? So now we can state that 3, 4, and 5 are Pythagorean triples. It's a true statement. So we're going to have to go ahead and write that out, right? So let's just think, how do we write it out? So we would say let's say this is a true statement based on the Pythagorean theorem. Okay, this is a true statement based on the Pythagorean theorem. Yeah. Okay, now I'm going to do the second one just to make sure that we understand what we're doing. So again, the numbers are already there, right? We're not trying to find any missing length the way we did yesterday, but we are trying to figure out whether this is true, whether this can be considered a Pythagorean triple, right? Through the Pythagorean theorem. That's how we're going to prove it, right? So we're going to go ahead and do number 2. So we do exactly the same thing. So I'm going to go ahead and have my right triangle. here's my 90-degree. Now we're going to do step number 2, identify the lengths of the legs and the hypotenuse. Before we do that, we need to identify our sides, right? So again, I remember that across from that 90-degree angle is my H, or in other words, my C, right? It's exactly the same thing. So that means this is my A, and this is my B. So again, you should be thinking, okay, what is my H? My hypotenuse is the longest side. So which one's my longest or my greatest number here? And that's 10. So I know that my hypotenuse is 10. Now my B is 6 and my A is 8. Or it could be switched. Remember, the length does not matter. So now we're going to go ahead and prove it through the Pythagorean theorem. Right, so we need to recall Pythagorean theorem is a squared plus b squared equals c squared. Now I'm going to go ahead and replace these numbers with the variables. Sorry, the variables with the numbers. So I know that a is 8 squared. I know that b is 6 squared. And lastly, I know that c is 10. Now we're going to go ahead and solve. We need to make sure that this a squared plus c squared is going to equal this 10 squared. 8 squared is 64. 6 squared is 36. 10 squared is cn. So now if we go ahead and add these two numbers, what does that give us? 100 equals 100. Is 100 equal 100? Of course, if you say you don't, then check yourself again. So now we can go ahead and rewrite this is a true statement because it is proven through, the Pythagorean theorem. Right, and that's how we're gonna go ahead and prove the next two. Okay, so we're going to use the Pythagorean theorem to prove whether they're Pythagorean triples. So now next for your Tuesday test, the first 4, you're going to have to find the missing side. So remember, we did that yesterday. If you don't remember, go ahead and take out your notes or look at your notes. However, you should know exactly how to do these. But you also have peers around you that are more than willing to help you. And then the back is exactly the same. Okay, so find the missing length. Within all of this, you have a few patterns that hopefully you guys catch on. If not, then we're gonna go ahead and do that together on Wednesday once I come back. But there is a pattern, there's always a pattern. So look out for that. If you have any questions, ask your peers or Mr. Garcia. I'm pretty sure he's more than happy to help. Okay. Please stay on task. Have a great afternoon. Toodaloo.